Okay, right, welcome everyone. Interesting topic today is about the hierarchy of action core, and let me explain why this is important, because better we understand it, better we can rule our lives. Now, uh, so out of our interaction with external world, what we've got is we've got our brain here, right? And there is particular stimuli. It gets into our brain. Brain changes a state, and then we get the reaction. So reaction, that could be anything. It could be action, could be just thoughts, which would lead to action or learning, whatever. But in this schema, what we've got is impulse or stimuli from the outer world is getting into our brain, and depends on the brain. There is some reaction to the environment which did generate that particular stimuli, and there is a hierarchy of those, and that hierarchy depends on how primordial uh, neural part of neural system is involved. So if we have a hierarchy of parts of neural system, so we've got our spine, right? Spine with nerves to legs, to arms, to some other organs like heart, stomach, and so on and so forth. Then we have a brainstem, right? And then and this is very simplified version, but you get what I mean. Well, hierarchy there, and then we get our cortex on the top. So this the lower part is the most ancient, right? Then stem is brainstem is newer, then spine, and the cortex is the newest invention, right? And what happens there? Uh, that means that if there is a hierarchy of parts of the brain, so that means uh, different stimuli are getting into our neural system, and they are invoking different reactions. And it seems like this hierarchy of stimuli is affecting different parts of the brain, and the stimuli themselves, or the state of the brain in results of stimuli, could be also be seen through hierarchy lens, right? So for example, when we've got like a pure pain from touching something sharp, where skin breaks and that sharp object is interacting with our nerves directly. Let's say here is our spine, leg, arm, right? So um, we step on a spike, and the stimuli from that neurons are going directly into a spine, generating particular response there, like they're designed for that, returning the reaction signal, and we uh, move our foot away from a spike, for example, or pay attention, and only later the stimuli goes up in the brain, and some agent here, which is us, is feeling the pain, right? But immediate muscle reaction is faster than we feel it. So sometimes you can observe it when you get you see the hand is already damaged, but you don't feel pain because like not enough time passed for a signal to go through the spine upstairs and make our agent to feel what's going on, right? So and that's immediate pain, right? Like when you are touching a hot stove and stuff and so on. Some acute physical pain, then chronic pain. That's the next stage, right? When like stomach, there's a pain in the stomach or pain in the head, and it's just like not stopping. So and let's say we have a neurons there, and they're going to our pain center in the brain. Pain center is generating those signals, and then our again agent, wherever it is, because again that's the mystery of modern world. Well, who is feeling what we feel? Who are we, right? So I'll call it an agent because it's quite similar to uh, reinforcement learning, because reinforcement learning is just like some agent in the model, inside of the model, is learning through stimuli what to do and what not to do. So I suspect like they also do feel a pain, so to speak, if we can transfer that to them. But like animals do have an agency themselves, right? So suffering, whatever that means, and then we get to emotional pain, right? So we've got negative emotions and positive emotions, and emotions are the feelings generated in the higher parts of the brain. So again, the hierarchy there is, for example, this is a brainstem, this is a brainstem, whatever. Here we've got amygdala, our fear thing, and then the brain on the top, and then the eye here, and the eye observes the thread, sending signals directly to amygdala or some uh, hippocampus part, and then our agent does experience particular feelings. It does something like if agent is afraid, and that could be a cat, antelope, or any other sort of animal, and they just like see something, they get scared and they run away, right? Or if we are talking about predators, then a predator sees a prey and getting excited, it's gonna eat soon, and they chase them, also feeling something interesting, some emotions, let's say, uh, in in that sense, but uh, they don't have a lot of cortex capacity, so most of the uh, heavy lifting is happening in the lower parts of the brain, like in the brainstem and those uh, relatively old parts of mammalian brain, like amygdala, hippocampus, hypothalamus, and so on and so forth. Right? Or again, and that's the combination of stimuli, right? Important part here is that so emotional, cultural. Yeah, we're gonna get to that later. So, and moods and diffuse feelings, this could be more for neurofrontal cortex, and not only for mammalians but for humans a lot, because we've got speech abilities. So what happens there is, here is our hemispheres here. Here is the stem there and the spine, and what happens there, so we didn't see anything, right? We didn't hear anything, but we just created some virtual reality in our brain, started thinking about uh, childhood traumas or some childhood events which generated emotion of, for example, a emotion of shame, right? Shame when we did something we didn't mean to, or it was bad for our reputation, or we were stupid and young, and so on and so forth. But the main part here is senses are not involved, right? Is whether everything is happening inside of the cortex and its convolutions. So what it means is the state of the agent changes without external stimuli, and that's the uh, highest level of emotions in terms of uh, the complexity and our hierarchy. And for that matter, uh, oh yeah, well, interesting part there, we even might feel something without a previous experience. So we can have a fantasy about the world and put ourselves in that new created artificial world and imagine some stuff happens with us and we feel it. We literally feel it. What I mean by feeling, not just our agent is experiencing particular things, but those feelings through the stem are sending signals, and blood pressure goes up. Blood pressure goes up. Uh, Start sweating, and so on and so forth. That's the physiological response, right? Response. And why that's important? That important is in order to have that, you have to have gear to have that, right? What I mean is, so for example, if you ask a slug or a spider to fantasize about a future, they won't be able simply because they do not have anatomical structures in their brain capable for doing so. So basically, they don't have particular gear to do so. Right. Moving forward, moving forward to external and internal, and that's probably I jump straight from the previous message, right? So brain can doesn't just passively receive reality. It is constructing it. So if we've got the like external stimuli, the stove, the snake, the email from our boss, and again, this email from our boss really depends on if we have not enough experience, we are just some kind of person who is afraid to lose that job. So that's gonna create a lot of stress. For example, if email is not pleasant, stress. However, if we do if we are experienced, or moreover we've got counter offer from the competitor with higher wages, this same email could lead to positive feelings, right? Positive feelings, because now we think, all right, that's a good excuse to leave this job and go to the next one, and that's the relief, that's the improvement of quality of life. So what that means is uh, the reaction mostly really depends what happens in our brain. So if we train ourselves not to be afraid of particular things, the same stimuli could cause not that bad feelings compared to if we didn't train. So the complex feeling are mostly the brain construction. That's right. So the richer the feeling, the more of it is of you and not the world, and the humbling your suffering is an object. Like, okay, constructing, framing, what we want. Okay, that's not what I wanted to say, but anyway. So So the important part there. So how it works regarding the pain. Again, getting back to my favorite part is natural selection and the how it stayed with us for a long period of time and why we have this hierarchy. So hierarchy there is for understanding the uh, stimuli, complex stimuli. Yeah. So for example, pain. So we got a pain reaction, right? So uh, skin cut, skin cut, right? Uh, neuron engaged, engaged, action, action, right? So what we have here is that's the schema. Now there is only one neuron involved, right? Or one, two, whatever. Let's say one neuron involved, and the reaction happens afterwards. So what happens there? So what we've got first generation of our imaginary ancestor, and we've got normal distribution where those ones didn't react, those ones reacted too much, like right, got mad about little cut, and those reacted normally. That's first generation. The second generation, those ones only who went to the next generation. Again, they've got the same normal distribution again, and also those ones didn't react to some different stimuli. Those ones did react, but overreacted, and again, so that thing happens like 100k generations over and over, and in the end, we get some normal distribution of normal reaction to the pain, right? But the thing here is why it's so primordial, because the complexity of the system for the reaction is low. What it means is that let me draw it there. So it requires just one neuron cell. Let's say one cell for transmitting the signal, one transmitter, and one muscle fiber, right? So um, in order to orchestrate it, it's quite simple, right? Because you've got one player, second player, third player, and this is why it's working so well, and it was working millions of years. Because like the less complex the system is, the higher that you are survival chances, right? So there are okay, so low complexity, I'll write it there, right? Low complexity. Now, getting to the next one, and next one was after pain. So let's say like primordial emotions, which could be detected in some old ancestors, right? So let's say first dinosaurs, reptiles, and so on and so forth. So fear, for example, or some hunting excitement. Roughly the same thing. However, in order to make this thing working, let's say fear response or seeking response, right? Let's say like seeking is more primordial than fear. Fear is the next one. So seeking emotion, right? Seeking emotion requires, so in order to seek something, you have to consume information and you have to receive the information. So you have to have at least sensors, right? Let's say some worms have their like spots like eyes when they consume light information. So let's write it here. So let's say light sensors, light sensors, uh, chemical sensors, chemical sensors. What else? Uh, Sound sensors, let's say, or what was it? Sound appeared from the vestibular sensors, right? So vestibular sensors. So the creature's supposed to know where there is vestibular sensors, right? It all goes into sensory part in the brain, and then generating, then making assessment of those signals and decides whether it's getting excited or not. Is it enough information, and is that information is good enough to excite or get bored, whatever. Now and then that state is meant to move body in space, and that requires muscle orchestration. So they said like body muscles, right? Body muscles, and then maybe mouth muscles, mouth muscles. So what I'm trying to say here is the next what was it? Stimuli, external, internal, brace. Hang on. Yeah, affection. So the next part in affection requires more moving parts. So you've got light, you've got chemical, you've got vestibuli, you've got like different body muscles and so on. And so what that means is this thing, in order to work, requires more sophisticated selection. Sophisticated selection. And that means in order to have this behavior to be working, less creatures would go through space and time in particular. So the less creatures are going to be in the next generation due to the complexity, because complexity is going up, complexity is going up, right? So that's an important part in our hierarchy, and that means the way of that mechanism to work is less robust than the previous one, right? So simple pain is much more robust in terms of the reaction and uh, making that functionality work is much easier than this like complicated seeking system, while the seeking emotion is also very primordial, and we can't really say that is the same as complicated human emotions about social status, for example. So if we are talking about uh, primates and our social emotions, so what the complexity is in the following way. So you've got your brain. Hang on, let me draw it. All right. So we've got our brain here, our hemispheres, right? We've got our eyes, we've got our ears, we've got our noses, right? A smiley face, and then so what happens here, and why is even more complicated than that? Because it requires first a lot of stimuli to draw a picture what happens in the group here and now, and it's going to happen tomorrow or was happening yesterday. So what we need for that, we need memory. We need really sophisticated memory because we have to remember a lot. We have to remember others' actions, others' mimics, behaviors, and so on and so forth. And that means we have to remember context of the tribe where we live, right? So that requires a lot of memory, hence a lot of memory neurons, right? Neurons. Then it requires uh, processing and understanding, right? So we have to understand that smile is smile, and friendly hand waving is friendly hand waving, and is not threatening us. So that means we need to have a lot of processing capacity or processing neurons, right? Next thing, what we have to have is just acute senses. So we have to have good eyes to see what happens. We have to hear a lot. So senses. sensors, and they're neurons as well. Neurons, right? So because sensors are neurons, obviously, right? So you've got neurons in your eyes, you've got neurons in your ears, and so on and so forth, in your nose. So that's that. Uh, and right, yeah. So, and what I mean is, so the complexity of the stimuli rise exponentially. So if we get like the graph there, and like let's say pain is there, right? So what we need, just one neuron, right? Then we have like seeking behavior for a worm, and it's gonna be there as complexity, and here's the number of neurons, and that's we draw the graph like that, right? So seeking of food or whatever, right? Let me. It's hard to see my graph. Let me put it there. Right, seeking. So it requires, let's say, 10 plus e 10 neurons, right? And that's going to be there, and that's there. And now we are getting to complicated emotions like shame, guilt, grief, and so on. And that requires, like, I don't know, 1 plus e 25. Like I'm making those numbers up, but you get the idea. So we have to have number of neurons there and the complexity of the emotion, which is like, let's say, grief, right? Grief. Uh, and it's there. So what we have in the end, that the more complex emotion is, the more gear it requires, more neurons, more anatomical structures in the brain it requires, right? So what that means is like and hence this is where hierarchy is getting to us. So a pain is a simple thing which is like working as a Victorinox knife, or how do you call that? Whatever. Yeah, then the primitive emotions like fear and seeking emotion and what else, lust. Also, they don't require a lot because they could be found in some crocodiles and turtles and so on and so forth. And then we get to our complex social life where we have to track all our tribe members, their emotions, their states, their health, their uh, intentions, and so on and so forth. And in order to have all that in place, we have to have much more neurons in order to keep up. And the selection of human beings is going that way in particular. Well, because as we know, groups of Neanderthals were much smaller than what? Okay, yeah. So the bigger the group, the more complex the behavior, and more gear we have to carry in our skull in order to keep up. So so let me clean this up. Super drawings, right? So what we have, okay, and now the control of it. So probably you're gonna read it yourself, but like I'm going to talk about the following. So basically, what happens with us, the emotion itself, emotion is the state of an agent. Well, I don't know what agent it is, right? A state of the agent which is determined and partly genetically, actually, and partly through received training. That's very important. What it means is we have genetic proclivities towards particular emotions. So if we see sad face, we most likely get so ourselves as well because of like mirror neurons in our heads. However, if we train ourselves not to pay too much attention to sad faces, and next time we see a sad face, for example, we just remember our training that sad face and that not necessarily has to sad us, and we just don't, right? So we keep our emotions at bay. Important part there is, apart from that, some things we can control, some things we cannot control. We have to understand that it's easier to put those things under control. Putting things under control requires the following. So we've got our neural network there, right? Neurons are connected, let's say. Okay, and here is our eye with stimuli of, let's say, bad behavior of somebody towards us and so on. And the neurons themselves are genetically predisposed to particular reaction. Now, when we train, we teach our neurons to have different connections when we see particular stimuli, right? So let's say that one is in green, that one is genetic one, that one is genetic one, that one is genetic one. And usually the signal goes through this, then this, then this, and so on, right? So when we train ourselves, we force our neurons to use different pathways, and this time it's going to go there. First time it's going to be hard, but then it's easier and easier, and in the end it's getting really easy, or it's becoming our nature. What it means is it's semi like a push bike. So first time you try to ride a push bike, it's quite hard because you simply don't have anatomical structures in the brain responsible for push bike riding. But more you train, more neural connections between existing neurons is getting formed, and more you practice, the more robust connections are, and then it becomes your second nature. So exactly the same thing here is with emotions, right? So in order to control it, you have to train yourself. Well, first, resist the temptation in the first place. So, for example, if your hand is reaching a mobile phone to see another rubbish content, you are telling yourself that it's not probably a good time to spend, and I would probably have to resist that temptation. And more you do that, easier it becomes with time, especially if you have different things to do. So, for example, create a video of explaining that, how to do that. So that's that. A stimulus hygiene, right? Again, if your eyes don't see something and they don't receive that stimuli there, then the temptation is lower because like it's only in your brain, in your imagination, if it's not in front of your face. So what else we've got here? What actually works? Stimulus, like I said, cognitive reprisal, change the meaning attached to the events, not suppression, reframing. Yeah, yeah. Well, that's also complicated things to do, but if possible. What it means is, for example, you're trading on the stock market and you've lost. You've lost. So let's say I've lost. So let's say instead of telling market punished me, we could say, what kind of information can I derive out of that event? And most of it say, what I'm done wrong, I've done wrong, right? The second one, what I could foresee, I could foresee, and now we are reframing that in a way that it's not just a punishment but a lesson. And if it's a lesson, that means we have to extract useful information out of it and to use that information in our future good. So something like that. Then uh, another important part is this, like, mindfulness. Mindfulness is what I call it is, for example, your agent, your agent is feeling anger, right? So it pushes you to react. It pushes you to do something towards this feeling. However, if you, or in this case, I am to myself articulate that anger is just genetic reaction to complex of stimuli. Moreover, anger is so old that even dinosaurs had it. So oh, I could look at it through other lens. Like anger is pushing me to do X, right? And how good is it for my personal life, well-being, and so on? And start even starting articulating it helps a lot to avoid unnecessary consequences, right? So if anger is pushing me to the X and the consequences are going to be devastating, then I would probably shouldn't do that. And even understanding at this stage what happens helps a lot, like prevents a lot of unwanted and consequential actions. Right. Acceptance. Stop fighting the thoughts. Act on values anyway. Yeah, well, that's quite hard, isn't it? Like when thoughts or do appear in your head uh, when you've got resentment, for example, you've been humiliated somewhere, and so on and so forth. It's really hard to stop it, and really hard to think about other things. And again, articulating that this is genetic, that let's say, 100,000 years, Homo sapiens creatures did experience such emotions with the similar combination of stimuli help them to survive. Doesn't necessarily mean it's gonna be good for you right here, right now. Hence, should work on how to stop that emotion to be felt by our own beloved agent. So, so that's that. And exposure sometimes stove until nervous system updates and its threat model. Yeah, so that means, yeah, that's really interesting part here. So let's say we've got our brain there, right? And the brain has fear sensor for, let's say, like, I don't know, spiders, right? And the the this sensor is overreacting all the time. So what we have to do is just we have to place our brain in a way that it has to relearn that spiders are not that dangerous now. Maybe they were when we were really small primates, I don't know, a kilogram or so, and then if spider bites, then we die, especially in a wild nature long time ago where spiders were bigger, but this irrational fear remains. So exposing ourselves to spiders and what it's gonna do, it's gonna just suppress the fear sensor. At least psychologists promise that. I don't know. I didn't try it myself, so this is what like books are telling. So exposing ourselves to the stimuli which are felt like dangerous, but they are not dangerous per se, then that helps. Right. So recap for this section, right? So what we've got: pain and emotion, a spectrum, not two categories. Yeah. So that's not, you can't really say this pain is pain, right? Because it, like again, every human being is unique, and for some, pain from cut, for example, for construction work, it means nothing because it happens every day. But for example, for a girl, it could be a tragedy. So that's that, and also that means is you can't really draw a fine line between complex emotion and simple emotion, because again, in order to do so, we have to have a measurable what parameters where like number of neurons, for example, are getting involved in particular brain reaction. So, for example, let's say if the stem, not the spine, stem, cortex, if the reaction goes through there and there, just like pain, okay, but that's not always the case because our agent is feeling it as well, and you never know what kind of other neurons are getting fired when this signal goes upstairs and then fires the neurons. Maybe a person is getting upset and depressed and then kill themselves. Like, also possible. Why not? So yeah, and that's the functional parameter, right? So as more neurons are involved, the more complex the emotion is, and different people fire different neurons, right? So if for some, just like little cut goes to spine and back and never reaches there because they got used to that little pain and don't pay attention. So agent is not getting excited about it. For the others, it's a separate thing. So let's say I draw the graph. I draw the graph is like back, right? Number of neurons and the complexity of, and it's something like that, right? So more neurons are involved in particular feeling, the more complex the emotion is, and the more sophisticated, and then the response reaction is going to be out of it. And if it's there, it's there. Like reaction is quite a rather primitive. Reaction is primitive. Right, so right. Wanted to conclude. Um, wanted to conclude with the following. Right, right. Conclude with the following. Conclusion. Conclusion is hierarchy of the state is hierarchy of the state is, yeah, does depend, uh, depends on hierarchy of the state depends on complexity of stimuli depends on the complexity of the stimuli and on complex of the brain or neural system, right? And hence response, yeah. The more legs, arms, or other limbs you have, the more things you can do with them, right? So if like a horse has hooves, you know, the abilities to do something are quite limited, and people with palms and so on, they have got extensive abilities and so on. So that's about hierarchy and conclusion. So I think that's it for today. Thank you for your attention.